guys, welcome to EduVersed. It's Afra Nawar. In our last class, we have learned about radioactive isotopes and radioactivity. Today in this video lecture, we are going to learn about electron distribution in an atom. How the electrons in an atom are distributed in the orbits. There are different energy levels in an atom. So what is electron distribution? The rule by which the electrons are distributed in the orbits is given by 2n square. So following this rule, this formula, we can get the electron distribution. This rule is called electron distributions. So this rule is for all the allowed orbits or paths of an atom. So it is 2n square. N is the 1, 2, 3. These are the successive number of orbits. That's the first orbit, third orbit, second orbit, like this. Here is the first orbit. In hydrogen there is only one orbit, but in other atoms there are also more orbits, like first, second, third, fourth, etc., etc., respectively. So it's the value of n. So 2n square. Then we can get the electron distribution in an atom. So how the electrons in atom will be distributed, or how are the number of atoms or the maximum number of electrons in an orbit of an atom. So some of these orbits can be filled and the rest can be empty. So following this rule, we will place the electrons. The maximum number of allowed electrons in the first orbit. So in the first orbit it is 2, second orbit 8, third orbit is 18, and so on. So 2n square. So n is the value of the number of orbits or energy levels. So first orbit it is 2, so 2n square. There is 4, and 4 into 2 is 8. There is the second orbit, and first orbit n is equal to 1. 1 is 1, 1 square, and 2 into 1 is 1. So 2. Second orbit 8, third orbit 18. Following this rule, n equal 3 cube. For example, there are different examples. Since orbits are also got energy levels, and each orbit corresponds to different energy for the electron in it. Because of the electrons, it have different energy, definite energy in them. There are some examples of the electron distribution. A lithium atom has 3 electrons. So of these 2 electrons are in the first orbit and third is in the second. So as in the first orbit, the maximum number of electrons can be 2. So 2 orbits have fulfilled the place in that. Then it goes to the second orbit. That is the third one. 3 electrons. First 2 is in the first orbit, and the third electron is in the second orbit in lithium atom. In the book we can know about the sodium atom. So there are 11 electrons in a sodium atom. So their electron distribution will be 2, 8, 1. How? In the first orbit there will be 2 electrons. There is a maximum number. Second orbit 8. We know the highest number is 8. 8 electrons can enter the second orbit. So here 8 electrons are present in the sodium atom. Again 1 electrons in the third orbit. As there are no other electrons, only 1 is present in the third orbit. And here it is 8, because 9 electrons cannot enter in the second orbit, because 8 is the highest value. So 2, 8, and 1. That is the electron distribution of the electrons in an atom. So these are distributed in definite orbits. So following this rule, the electron configuration of these atoms are given. These are the electron configurations according to the rule. In the next lesson, we'll learn about the electron distribution and the properties of the elements. What are the properties? Like cations, anions, how these are charged. So for this, you have to know the stability of the elements. Actually, the stability of these elements depend upon the electron distribution of the atoms. So first of all is cation. An atom by losing electron becomes positively charged, that is called cations, because like sodium, it loses one electron from the outermost shell. When it loses one electron from the outermost shell, that is, here is one electron, its electrons are negatively charged. Here is its charge, negative, electron negative, that it is releasing the electrons. Sodium is releasing the electrons, so it becomes positively charged. So cation donates one electron. So when any atom donates or loses an electron that is positively charged, that means that atom donates anything, it becomes positively charged. That is, electron is lost by the atom, that is becomes the cation. So it donates the electron to become positively charged. So sodium plus, that is, when it donates one electron, it becomes positively charged. Anion is opposite of cation, that is, it is negatively charged. Negatively charged ions. What is ion? Ions are the charged atoms. The charged elements are called ions. Ions are of two types, cation and anion. So ion, an atom by receiving becomes negatively charged by receiving electrons. So by receiving these electrons, it becomes negatively charged. So when any atom receives any electron, it becomes negatively charged, but when it donates one electron, it becomes positively charged, that is cation. Anion receives, cation donates. That's how they form compounds in them. But why actually this happens? Why the ions are formed? Why they tend to donate one electron? And why they tend to receive electron? And why they are negatively charged? Why these are positively charged? There may be questions in your mind. So this actually depends on the stability of elements. Like the properties of elements are basically determined by the electron distribution in their orbits. Generally, atoms become active or inactive or charged due to the difference in their electron distribution. If the last orbit has all the electrons, that is the maximum number of electrons can enter in them, that is 8 here. So then the orbit is completely filled because the maximum number of electrons are entered in that orbit. So if the orbit is filled with the maximum number of electrons, then it is stable. And every atom tends to go to such a stable state, because every atom wants to be stable. That is, their last orbit must have the maximum number of electrons in them. Then it becomes stable. So if the number of electrons in the last orbit or the highest state is such that it can complete it either by borrowing electrons or losing electrons, that is, donating electrons or losing electrons, and it will tend so. So to become stable, any atom can donate electron and any atom can receive any electron to become stable. Because in the last shell, it have to have the maximum amount of electrons. Because when the outermost orbit is complete, the negative charge of the electrons shields the equal number of protons in the nucleus. This reduces the energy of the system and the atom becomes more stable. It needs less energy and it becomes more stable. So this redistribution of the outer electron takes place by sharing electron with the neighboring atoms. So by sharing electron, it happens. Like the sodium, its electron configuration is 281. 11 is their atomic number, so 281. By losing this one electron, it can be stable because there is 8, and it is the maximum value of the electrons that can enter in the second orbit, 8. So it can be easily stable here. Again, fluorine. Fluorine is 9, 2, 7. But 7, then the electrons are 1, then fluorine. Here it is 2 and 7. So the last orbit is not fulfilled. So it can gain 1 electron easily to become stable. So which becomes easier, to donate or to release? So it can gain 1 electron here, to donate or by receiving. By receiving 1, it can easily be stable because it is the maximum value of the electrons. So here it receives 1 electrons. It receives plus, that is 1 electron is added. Then it becomes negatively charged as it is receiving 1 electron. And it is positively charged as it donates, that is minus, subtracting 1 electron. 1 electron is subtracted, is given. That's why it's positively charged and it's negatively charged. So now we'll know about the ionic bond. So the bond between the ions. These cations and anions actually form the ionic bonds. There is a chemical reaction. Going through any chemical reaction, they form bonds in them, or the oppositely charged ions. So during reaction between the metals and non-metals, metals are positively charged, non-metals are negatively charged. So these two metals and non-metals, to get the electronic configuration metals, that is the stable condition. To get the stable condition, the metals lose electrons. The metals always lose electrons as they are positively charged. So they become positively charged as they are losing 1 electron or more than 1 electron. So these are metals as they lose 1 electron. So these metals become cation, and the non-metals, they become anion as they receive electrons from the metals. So by receiving 1 electron, it becomes an anion. So there are force reacts between them, between the oppositely charged atoms or elements. So the electrostatic force. So the force is called the electrostatic force in them among the oppositely charged ions. So the electrostatic force of attraction between the metals and non-metals, that is the oppositely charged ions, this is called ionic bond in chemical reaction. So that's how ionic bond is formed during chemical reaction between the metals and non-metals, or cations or anions. So all cations are metals and all anions are non-metals. These actually form the ionic bond. Here is an example of ionic bond. It is potassium chloride. How it is formed? So potassium chloride is a chemical compound. It will come in your exam. We describe them. Many other compounds it comes. Potassium is a metal and chlorine is non-metal. All the non-metals are negatively charged and metals are positively charged. The atomic number of potassium is 19. Its electronic configuration is 2881. It can easily lose 1 electron in the last orbit. Yes, it will easily lose this one. To be stable. By doing this, it gets the stable configuration of argon 288, and it becomes positively charged potassium ion 288. So to become stable, it easily loses its 1 electron in the outermost energy level. On the other hand, the atomic number 37, its electronic configuration is 287, and it accepts 1 electron in the last orbit lost by the potassium. Why does it accept? To be stable. So when it becomes 8, its shell becomes fulfilled. That's why it accepts 1 electron. That's why it becomes negatively charged and it is positively charged. So by doing this, it is a stable configuration of that is the electronic configuration of argon 28818, and becomes positively charged. No, it will be negatively charged. So the equation is potassium is equal to potassium plus, so that is, it is positively charged. That means it will have released one of its electron. So when one of its electron is again added with the potassium plus, then it becomes the potassium. So potassium plus means there is one electron is absent. So when one electron is added to it, it becomes the potassium. A chlorine. Normally chlorine is 287. So when one electron is added with it, it becomes negatively charged, that is an anion. So it becomes an anion, it is potassium plus chlorine, is potassium plus chlorine minus, or potassium chlorine. Then the chemical compound is formed, or ionic bonds are formed. Potassium and chlorine. So this is the equation that we will write. Potassium and chlorine are oppositely charged. They attract each other by electrostatic force and remains together by giving potassium chloride, which is an ionic compound. So the whole one is an ionic compound because ions are oppositely charged here, and oppositely charged ions attract each other by a electrostatic force. It's a force between oppositely charged ions. In the figure, we can see that potassium atom 281, there is one electron. It is transfer of one electron, transfer to chlorine. It is transferred to chlorine, here it will say. So then it becomes positively charged. After the transfer of one electron, it becomes positively charged for donating it. And when it receives one electron, the chlorine becomes negatively charged, and they can get the stable electronic configuration of argon. That's how they form potassium chloride, because the plus and minus attract each other. So we have to write, in the example, write like this: bracket and then plus, brackets and then minus. These opposite charged atoms. So this is all about potassium chloride. So the ionic bonds are between the cations and anions. Without cations and anions, ionic bond cannot be formed. So this is all about today. Hope you guys understood this whole lecture. And the exam, these questions may come, you memorize them. Then these atomic numbers, all you can memorize in class 8. Okay guys, hope you enjoyed this video. Thanks for staying with us. Assalamualaikum.